Welcome back. This is part 4 and the final section to this presentation. And what will be discussed in this part will be based on nutritional strategies that may be needed while on a ketogenic diet. Prevention of seizures and optimization of human performance will be intertwined throughout this section, applying to both concepts. So can a KD cover all bases of nutrition? As we will see, the ketogenic diet alone likely cannot do all the work in preventing seizures and optimizing human performance. Many enzymes and other cellular processes necessitate vitamins and minerals as cofactors, which may not be completely fulfilled by the ketogenic diet. For starters, magnesium is a major mineral, and it's required for over 300 enzymes that utilize ATP and also help stabilize ATP. And if deficiency exists, then electrolyte imbalance could ensue, which places the cell at risk for irreversible cell damage. This is quite significant in the central nervous system, where deficiency is related to disorientation, seizures, weakness, and muscle spasms, and these symptoms are quite unfavorable with physical activity. And prolonged heat exposure can cause increased requirements for magnesium. The use of diuretics and alcohol can increase magnesium requirements, as well as prolonged bouts of diarrhea or vomiting. And people who consume caffeine quite often could also have increased magnesium requirements. It is crucial to have optimized magnesium concentrations during the application of the KD as to maintain electrolyte homeostasis within the central nervous system and skeletal muscle. Sources of magnesium include pretty much all plants because magnesium is a major component of chlorophyll, and small amounts of magnesium are found in milk, meats, and eggs. Supplemental magnesium in the form of magnesium oxide is not very well absorbed, so non-starchy dark green leafy vegetables are definitely recommended and fit well into a ketogenic diet. Zinc is very important because it's also required for nearly 300 different enzymes. So nearly all body processes require zinc. And we saw how the antioxidant defense network may be overwhelmed with oxygen toxicity, and we saw that the KD increases the defense network for antioxidants. If zinc concentrations are not optimal, then it's possible that these antioxidants will not be able to work as they should. And so ensuring that antioxidant defenses and cellular processes are intact will provide a strong platform for the proposed effects of a ketogenic diet. Zinc also has a role in the stabilization of cell membrane proteins, gene transcription factors, and receptor proteins for vitamins A and D, and also thyroid hormone. So zinc has a lot of functions that relate to homeostasis and overall body function. And so it's obvious that zinc is necessary, but the fact that CO2 is an aggravating factor in central nervous system toxicity and zinc helps remove CO2, this definitely elucidates the need for zinc. So something random comes up when I think about zinc, and if a mild zinc deficiency could possibly disrupt thyroid hormone receptors, could this induce a functional hypothyroid state? And I asked this question kind of for a foreshadowing of what's to possibly come later in this presentation. So the sources of zinc include protein-rich sources of meat like beef, lamb, and pork, and also plant-based foods like nuts and beans. Supplemental zinc in the form of zinc picolinate actually demonstrates relatively good absorption. And There are some factors that increase zinc absorption, and they include animal protein intake and low to moderate zinc intake. And there are factors that decrease zinc absorption, and they include phytic acid and fiber in whole grains, excessive zinc intake, and high non-heme iron intake, which is iron from plant food. So since the whole grains are going to be excluded in this diet, that might not be something that we have to worry about with zinc absorption. Now, mild zinc deficiency is difficult to detect, and unfortunately some people are at risk for marginal deficiency. So in particular though, persons that do not consume adequate amounts of animal-based foods are at risk. But with a ketogenic diet, many foods are going to be based on animal products like meats and eggs. So hopefully zinc will be provided in adequate amounts while on a KD. We already talked about copper, and it's required for many enzymatic reactions, just like magnesium and zinc. And it is closely linked to iron metabolism and plays a pivotal role in aerobic energy production, which is very important. And the aerobic energy production may be linked to how iron metabolism enables oxygen delivery. So copper is especially important for hemoglobin synthesis, antioxidant defense networks, dopamine beta hydroxylase, cytochrome C oxidase, monoamine oxidase, and regulation of many neurotransmitters. Of note, cytochrome C oxidase is the last catalytic step in the electron transport chain during aerobic respiration. This is important if a KD is used because fat metabolism requires mitochondrial metabolic machinery. Copper deficiency has been found to be linked to an increased risk for some neurological diseases, including Alzheimer and Lou Gehrig disease. Sources of copper include shellfish, nuts, and legumes. Meats may help with absorption of copper, just like it may help with absorption of zinc. So what about selenium? Well, it functions in at least 25 different enzymes and proteins, and it's especially important in the antioxidant defense network as a part of glutathione peroxidase, thioredoxin reductase enzymes, and selenoprotein P. If the KD can increase the concentration of glutathione peroxidase, then it is likely that there may be an increased need for selenium. Thioredoxin reductase enzymes are important in redox balance and control of reaction oxygen species generated during oxidative phosphorylation in the mitochondria. And finally, selenoprotein P may act as an extracellular antioxidant, but more research is needed to understand its role in humans. So if a KD can cause mitochondrial biogenesis and increased aerobic respiration workload, then it is possible that an increased need for selenium would arise to handle the increased amounts of ROS. Antioxidant capacity seems to be the major focus of seizure prevention via the KD, and thus selenium intake should be optimal. So the sources of selenium include seafood, meats, cereals, grains, and nuts. How about manganese? Well, it serves as a cofactor for many enzymes, just like zinc and copper do. Especially important in carbohydrate and nitrogen metabolism and the antioxidant defense network, particularly the superoxide dismutase enzyme within mitochondria. Sources of manganese include nuts, legumes, and tea, as well as pineapple. Meat and dairy negligibly contribute to dietary manganese. So nuts and legumes are also good sources of polyunsaturated fats. And like we mentioned earlier, 80% of the fats coming from the diet should be polyunsaturated and monounsaturated. Other sources of polyunsaturated fats include coffee, flaxseed oil, and mayonnaise. And these are all compatible with the ketogenic diet. So let's include vitamin C. We know that it has many functions. And as for human performance, carnitine production is vital for fatty acid metabolism and energy use. So this is fitting for a ketogenic diet. So as we exercise, we increase the free radicals that are produced, which might actually increase the need for antioxidants. So diets rich in fruits and vegetables supplies all antioxidant needs. Vitamin C is thought to donate electrons to free radicals, causing them to become stabilized. And vitamin C is also thought to help vitamin E function more effectively. In the prevention of possible outcomes of oxygen toxicity and exercise, vitamin C may help mitigate oxidative stress. Sources of vitamin C include citrus fruits, peppers, and green vegetables. So let's talk a little bit about vitamin E. It functions mainly as an antioxidant and aids in enzymatic processes involved in antioxidant defense networks. And vitamin E is especially important in reducing oxidative stress, which may be significant in lowering the risk of disease, including cognitive decline in certain cancers. So vitamin E is one of the most effective mechanisms for stopping lipid peroxidation, and luckily vitamin E acts primarily in lipid-rich areas of the body, including the central nervous system. This is extremely important when considering the effects of oxygen toxicity and its pathogenesis, as well as neutralizing oxidants that arise during physical activity and increased fat oxidation while on a ketogenic diet. Sources of vitamin E include plant oils, asparagus, almonds, peanuts, and sunflower seeds. And so remember that vitamin E is fat soluble, so to optimize its absorption, consumption of dietary fat is necessary. And in particular, the plant oils, since they are a good source of vitamin E, they're likely a good source of monounsaturated fats. And some of the plant oils that are good sources of monounsaturated fats include olive, canola, peanut, and safflower oil. Avocados are also a good source of monounsaturated fats, which are also thought to be cardioprotective. And all of these oils and avocados fit right in with a ketogenic diet. So what about those B vitamins? Since the ketogenic diet is predominantly comprised of fats, it is important to ensure optimal levels of vitamins that are responsible for fat metabolism. B vitamins have other responsibilities aside from lipid metabolism, but the focus remains on properties of a ketogenic diet. Vitamin B6 is necessary for the conversion of glutamic acid to GABA, which was mentioned earlier. This is also vital for carnitine synthesis, lipid metabolism, and ketogenesis. Niacin, vitamin B3, is necessary for carnitine synthesis and fatty acid synthesis and breakdown. Niacin may enhance the stability of ketone bodies via increased conversion of acetoacetate to beta-hydroxybutyrate. Biotin, vitamin B7. This is necessary for fatty acid metabolism. Pantothenic acid, vitamin B5. This is necessary for fatty acid and ketone synthesis. Sources of B vitamins include many things, like unprocessed grains, pork, milk, mushrooms, chicken, tuna, egg yolks, sunflower seeds, legumes, bananas, avocados, lentils, fortified orange juice, clam chowder, oysters, and cod. When they're all combined, they provide all the B vitamins. All B vitamins are important, but those mentioned are particularly important for those on a ketogenic diet and may potentially aid in its seizure preventative effects and fatty acid utilization during exercise. As it applies to human performance, B vitamin supplementation improves performance in deficient athletes, but no evidence exists for improved performance with supplementation in well-nourished persons. Nonetheless, exercise may deplete B vitamins in some athletes, so supplementation could potentially optimize performance. So would any supplements be beneficial? A multivitamin, multimineral supplement may be beneficial. Even though it is possible and feasible to consume a ketogenic diet and obtain all nutrients necessary for optimal functioning, it is still difficult and unlikely. And so this is why a supplemental approach may be favorable in certain instances. Iron deficiency is the most common deficiency in athletes, especially in female athletes. Energy restriction and vegetarian diets increase the risk for iron deficiency, but a ketogenic diet will supply an abundance of heme iron from its primary food, which are meats. Calcium concerns are more so directed at female athletes and persons on a ketogenic diet who consume very little dairy or have sodium-potassium imbalance, like we mentioned earlier. Vitamin D is best consumed via the sun, but dairy is also a good source. Improvement of performance via vitamin D supplementation is possible for those who are in deficiency range of 30 to 50 nanograms per milliliter. Amino acid supplements may be beneficial, like ketogenic amino acids, leucine, isoleucine, lysine, phenylalanine, tryptophan, and tyrosine. The branched-chain amino acid supplements also may be beneficial, which include leucine, isoleucine, and valine. But instead of using supplements, they can be consumed naturally, and they're found in chicken, fish, dairy, and eggs. Now, branched-chain amino acid supplements are commonly used and readily available, with leucine and isoleucine being ketogenic and valine being able to enter directly into the Krebs cycle. The properties of branched-chain amino acids provide an alternative source for ketogenesis and energy production, making their supplementation worthwhile. However, consuming amino acid supplements may disrupt blood insulin levels, and so getting them from natural sources, as I just stated, is recommended. Ketone supplements may be beneficial as well. So let's have a look at those ketone supplements. Ketone esters are essentially synthetic digestible ketone bodies, and they have been found to directly increase plasma ketone bodies. And dose size controls the degree of ketone body elevation. And the doses of these supplements usually range from 100 to 150 grams per day in divided doses. The current ketone esters under study include the 1,3-butanediol monoester of beta-hydroxybutyrate, and this monoester actually is converted into beta-hydroxybutyrate once inside the body. The other one is glycerol tris-3-hydroxybutyrate, 3-GHB. Therapeutic ketosis has been mentioned earlier, and it's a plasma ketone body concentration of 2 to 7 millimoles per liter. And this can be obtained with ketone ester administration, as it's been seen in rats, mice, pigs, and humans. But further research needs to be conducted to determine if the ketone ester administration can prevent or control seizures. So let's look at some other strategies for seizure prevention. The first is acquired tolerance to hyperoxic exposure may be accomplished via induction of antioxidant enzymes by exposure to non-lethal levels of hyperoxia and or hypoxia. Adrenalectomy, hypophysectomy, hypothyroid state, and alpha-adrenergic blockers can reduce the severity of oxygen toxicity. Perhaps there are pharmacological and or nutritional solutions that could be rendered that mimic these conditions or states, as we saw that marginal zinc deficiency may mimic a hypothyroid state, and that's why I mentioned that question earlier on. Caffeine has been shown to be a vasoconstrictor within the central nervous system, which may prolong the latent period associated with oxygen toxicity. But caffeine inhibits aldosterone, and aldosterone regulates potassium and sodium. So there could be a potential problem with caffeine and a ketogenic diet. Overall, this slide alludes to the unlikelihood of universal treatment or preventative measure. The world is composed of and works via interactive systems, and each system is interdependent on all the others. Therefore, multiple approaches will likely be necessary to accomplish the proposed goals of a ketogenic diet. So looking ahead, what ought to be the directions of future research regarding the KD? This could help elucidate the potential regional and cultural differences in metabolism that may be linked to hereditary patterns rendered by environmental pressures, granting a deeper look into possibilities of nutrition and its association with genetic expression. Some studies have shown that the ketogenic diet may be more effective in children because of their younger brains having a peaked ability to transport and utilize ketone bodies as an energy source. However, studies also show retardation in physical growth. Similarly, prolonged fetal utilization of ketones is associated with reduced growth and impaired intellectual development in the offspring. So age and developmental stages may have a strong impact on how a ketogenic diet affects the body. With the inclusion of consistent carbohydrate intake, the cyclical and targeted KDs may decrease a ketogenic diet's efficacy, especially in preventing seizures. For athletic purposes, carbohydrate intakes may boost anaerobic power but diminish aerobic potential. Although anaerobic threshold was not mentioned in this presentation, it may be important to briefly mention. More anaerobic energy production produces more lactate, but this requires glycogen. If glycogen stores are low while on a ketogenic diet, could lactate levels remain relatively low and easily cleared by the body? Exercise increases monocarboxylate transporters, which transport both ketones and lactate. Potentially, a ketogenic diet could artificially increase the anaerobic threshold of athletes, but further studies could look at this. So, will short periods of exposure to the diet confer long-term benefits, such as genetic switching or the capability to have some sort of memory? For instance, once keto adaptation initially occurs, will the body be able to return to this adaptive mode if the diet is discontinued and then started again? And finally, discovering the nutritional and pathological consequences of chronic use of a KD beyond what is currently known may be beneficial as well. In addition to the already mentioned adverse effects, other effects do exist and include hyperuricemia, hypomagnesemia, decreased amino acid levels, and carnitine deficiency. So if nutritional strategies are accounted for, will these and other adverse effects still arise? In conclusion, what can we glean from this presentation? Well, desired weight loss, diminished food sensitivities or allergic responses, and prevention and management of chronic disease may result while on a KD. Neuroprotection and seizure prevention, including oxygen toxicity seizures, may result while on a KD. Enhanced submaximal exercise and glycogen-sparing effects leading to heightened aerobic performance may result while on a KD. And all the effects of a KD and ketosis depend on several factors, including genetic variability of metabolic expression, dietary discipline and planning, and exercise regimens undertaken while on a KD. So the application of a ketogenic diet will not demonstrate identical effects across the population. However, the common genetic basis for human metabolism ought to provide similar adaptive responses that enable a familiar microevolution while on the diet, promoting favorable generalized health effects not seen with contemporary diets and affording human performance outcomes comparable to agriculturally based diets. And this concludes the presentation, and here's a list of the references. And I'd like to just simply say thank you for your undivided attention, and I hope you have enjoyed this presentation.